So in the last video, we talked about philosophy as that which does certain jobs. Perhaps philosophy is that which theorizes when science is silent and does so in a way that's systematic and obeys rational norms. Second, perhaps philosophy primarily lays the groundwork for sciences by clarifying their conceptual and linguistic frameworks. And third, perhaps philosophy is designed to detect contradictions or tensions in your beliefs, beliefs that don't fit very well together, thereby creating a sense of puzzlement that then provides the basis for progress, allows you to sort of theorize in a new way and think in a new way. And I'm going to give you an example of philosophy creating aporia, this sense of puzzlement. And it's called the Sleeping Beauty problem. So here's a little bit of background. This background is useful not just for understanding this problem, but for thinking about issues in general, which is why I chose this problem. So a proposition or a claim is what a declarative sentence expresses. And that raises the question, what is a declarative sentence? And the idea is really simple. A declarative sentence declares, it says something about the world. So anytime you're just describing the world, you're uttering declarative sentences. You're also uttering declarative sentences when, more generally, when you say something that's supposed to be true or false. So if I say this table is flat, that's a declarative sentence. If I say my dog has brindle fur, that's a declarative sentence. If I say I can jump over the moon, that's a declarative sentence. The last one, of course, is false. And a proposition is just what's expressed by any declarative sentence. Now, why are we drawing a distinction between what a declarative sentence expresses and the sentence itself? Well, there's a variety of reasons, but here's a really simple one. Two different declarative sentences might say the same thing about the world. So if I say the table that I'm touching right now is flat, I've expressed a certain proposition. And you might think I'm expressing the same proposition if I say the table in my basement is flat, since in each case I'm talking about the same table. More generally, if I say the table is flat in one language and then say it in another, I express the same proposition in each case. What's a belief? Now, this is a really important term for us, and we'll talk about this again when we get to epistemology. That is, I'll reiterate and say the same things I'm going to say now because they're important. There's a variety of different uses of the word belief in ordinary language, and that's fine. But we're picking a particular use of the word belief that's common in cognitive psychology and psychology more generally, and common in philosophy. And on this use of the word belief, all a belief is this: the mental attitude of affirming a proposition. Now, you might think, of course, that's what a belief is. But sometimes the word belief is used to denigrate. It's used to say something is bad or weak or inferior. Like somebody might say, well, that's a belief, not a fact, as if the word belief means opinion. Somebody might say, well, I believe there's, milk in the refrigerator, to indicate that they're not confident that there's milk in the refrigerator. When in this class, as in cognitive psychology, when you call something a belief, you're not denigrating. You're not saying that it's somehow weak or inferior or bad. All a belief is something you think is true. So if you think you have a hand or you think you have hair, then you have a belief that you have a hand and you have a belief that you have hair. Beliefs are just affirmations, mentally affirming a proposition. It's also worth noting that we often talk about beliefs as if they're all or none. So we talk as if look, you either believe that there's at least 100 people in this building, or you don't believe it. But in fact, beliefs often come in degrees. So when someone says, do you believe that there's at least 100 people in this building? You might say, well, I think there is, but I'm not very confident. You might indicate that there's some amount to which you're willing to affirm that proposition, but you don't want to sort of go whole hog. What that indicates is that beliefs may become in degrees. You can believe something more or less. A credence, this is just a technical term, that's why it's italicized here. It's not a term in ordinary language, or at least the use we're giving it. It doesn't necessarily match its ordinary language use. A credence is just a degree of belief. So if you're 90% confident in something, that is your belief that it's going to snow this week is 90%, then you'd say your credence is 90% that it's going to snow this week. A credence is typically measured on a scale from 0 to 1. The idea is 0 means 0%, 1 means 100%, 0.9 means 90%, and so on and so forth. So 0 is certainty that a claim is false, 1 is certainty that a claim is true, and 0.5 is total neutrality about whether the claim is true or false. And we'll come back to this scale later because it's useful to know. Here's a question. If you know that the probability that an event will occur is 75%, what should your credence in the claim that event will occur be? And the answer is 0.75, okay? Because I'm just telling you, this is how you talk. If you know the probability that it will rain tomorrow is 33%, what should your credence in the claim it will rain tomorrow be? Well, 0.33. Okay. Now here's a question about probability. What is the probability that a fair coin will land heads on any given flip? Well, most of you probably say 50%, and that means that your credence in the claim that a fair coin will land heads should at least ordinarily be 50%. Okay, or 0.5. Okay, so this is all just background. Now comes the Sleeping Beauty problem. So here you have Beauty, and here you have some mad scientist, we'll call her X. And X says, "Welcome, Beauty, to my Sunday night experiment. Here's how we're going to proceed. Tonight, after you fall asleep, I'm going to flip a fair coin. If the coin lands heads, then I'll wake you up on Monday morning. I won't tell you that it's Monday, and you'll have no way to find out that it's Monday." And Beauty says, "Well, why does that matter?" And X says, "I'll get to that." Then X says, "If the coin lands tails, then I'm going to wake you up on Monday. I'm going to let you fall back asleep Monday night and then wake you up again on Tuesday. But once I put you to sleep on Monday night, I'm going to erase your memory of ever having been woken up and the entire events of Monday." And that matters for the following reason, as Beauty will explain. She says, "I see. When I wake up, I won't know if it's Monday and the first time I've been woken up, or Tuesday and the second time I've been woken up. Because if it's Tuesday, you're going to have erased my memory of it having been woken up on Monday. So from my point of view, it's going to look like it's the first time I've been woken up." But Beauty says, "I already know this going in. So anytime I get woken up, I won't know whether it's Monday and the first time I've been woken up, or Tuesday and the second time I've been woken up." And X says, "Exactly. Whenever I wake you up, I'm going to ask you the same question. And the question I'm going to ask you is this: what is your credence in the claim the coin that I flipped to decide when to wake you up landed heads?" And Beauty says, "Sounds good." So let's look at how this proceeds. Now, there's a handout, an activity sheet, which if you're not in class, you can sort of pause the video here and go read through the problem and fill out the activity sheet to make sure you understand it. But I'll now go on with an explanation of the basic idea here. So X is going to flip the coin, and Beauty's going to sort of get ready. X then says to herself, or thinks to herself, this: here's what's going to happen if the coin lands heads. I'm going to, on Monday, wake up Beauty, but not tell her it's Monday and not let her find out. And then I'm just going to say, state your credence in the claim the coin landed heads. And Beauty presumably would say 0.5. But if the coin lands tails, here's what I'm going to do. On Monday, I'm going to wake up Beauty and say, state your credence in the claim the coin landed heads. And then, after Beauty goes back to sleep, I'm going to erase her memory of ever having been woken up so that she doesn't know that she was woken up in the first place. And then on Tuesday, I'm going to wake her up again, not telling her it's Tuesday, not giving her any way to find out, and say, state your credence in the claim the coin landed heads. So when Beauty's woken up, she won't know whether it's Monday and the coin landed heads, or it's Monday and the coin landed tails, or it's Tuesday and the coin landed tails. From her point of view, when she's woken up and asked this question, say your credence in the claim the coin landed heads, she could be in this scenario, or this scenario, or this scenario. She has no way to decide which it is. Okay, so now suppose you're Beauty. What should you say? When the mad scientist wakes you up and says, state your credence in the claim the coin landed heads, what should you say? Should you say 0.5? That seems intuitive, right? But here's the problem. When the coin lands heads, you get woken up once. When the coin lands tails, you get woken up twice. And now one way we can think about this is as follows. The chance that the coin landed heads is 1/3, not 1/2. Why? Well, Beauty can be in any one of these three scenarios. Or I should say, Beauty should say the chance that the coin landed heads is 1/3, not 1/2. Beauty can be in any of these three scenarios. She has no reason to believe that one of them is more likely than another. So she should think of these three scenarios as equally likely. That is, she should assign the same probability to each of them. And I'm going to walk through this more slowly in a second, but hopefully you can now see the idea. If she should assign 1/3 to the probability that it's Monday and the coin landed heads, and 1/3 to the probability that it's Monday and the coin landed tails, and 1/3 to the scenario that it's Tuesday and the coin landed tails, then she should assign 2/3 to these two down here and 1/3 to this one up here. Well, this is the heads one. These are both tails ones, so it would be 1/3 heads, 2/3 tails. So she should think all of this. The chance that she's in scenario 1 is the same as the chance that she's in scenario 2, which is the same as the chance that she's in scenario 3. Let X stand for the chance that she's in 1. Well, since the chances of these are all the same, she should say scenario 2 and 3 are also X. So she should think this: the chance that I'm in 1 is X, the chance that I'm in 2 is X, the chance that I'm in 3 is X. She knows she's in one of those three, so she knows the probability of this, and this sum to 1. So X plus X plus X equals 1. So X equals 1/3. So what's the probability that she's in this scenario up here, where the coin has landed heads? It's 1/3. Okay, and the chance that she's in one of these two down here, where the coin has landed tails, it's 2/3. It's the probability of scenario 2 plus the probability of scenario 3. So she knows that the chance that it landed heads is 1/3, and she knows that the chance that it landed tails is 2/3. Okay, so she can conclude that the chance that the coin landed heads is 1/3. There's an argument for when you wake her up and you say, state your credence in the claim the coin landed heads, you should answer 1/3, 30.33. But here's an argument going the other direction, that Beauty should say the chance that the coin landed heads is 1/2, not 1/3. And the argument here is very simple, right? The probability that a fair coin lands heads is 1/2. It's 50%. When someone says state your credence in an event, and the event has an objective probability like 50%, you should just say that whatever that objective probability is. So Beauty should just say 50%. And there's a lot of interesting ways to elaborate this argument for 1/2. I'll just very briefly give you one. So suppose we back up here. So we're going to go back to the very first moment of the experiment when the scientist says, here we go. Now imagine if the scientist flips the coin. So boom, coin is being flipped, and then immediately says to Beauty, state the probability of the claim the coin landed heads. Well, it seems clear in that case, Beauty should sort of open up her eyes and say, well, 50%. Of course, right? And that seems obvious. But if it's 50% now, how could you say anything else later? Because there's a simple principle for assigning probabilities, which says this: if you should assign a probability of X at one time, say 50% at one time, and you get no new information about the event before another time, then you should assign the same exact probability X at that other time, say 50%. So if Beauty should assign 50% at this very first moment, if the guy asks her what's the probability that the coin landed heads, then she should assign 50% at any later time unless she's acquired new information about the coin, what the coin landed on. Well, has she acquired new information when she got woken up? Well, she knew she was going to get woken up on Sunday. That is, I should say, put it this way. On Sunday, she knew she would be woken up on Monday if it landed heads, and Tuesday if it landed, Monday and Tuesday if it landed tails. So she hasn't acquired any new information when she gets woken up. But if she hasn't acquired any new information, then she should assign the same probability. Which means if she should assign a probability of 50% on Monday, then she should assign on Sunday night when he first asks her, then she should assign a probability of 50% on any of the other nights, any of the other wakings. Put another way, it means this: if she should assign a probability of 1/3 when she's woken up, then she should say 1/3 way back here. If the scientist just flips the coin right in front of her face and says, what's the probability it landed heads, she should say 1/3. But that seems crazy. So that's an argument for 50-50. And what we have now are two seemingly good arguments. A good argument for the claim that when the scientist says, state your credence in the coin landed heads, Beauty should say 1/3, and an argument for the claim that she should say 1/2. And this is a genuine puzzle, a genuine paradox, because there's widespread disagreement about what the answer is. There are people who argue that 50% is the correct answer, and there's people who argue that 33% is the correct answer. There isn't convergence. That is, statisticians disagree with one another about this. Philosophers disagree with one another about this. It's unclear what the answer is. And what that means is we need to do some conceptual, clarification in order to make progress. Okay, so let's move on. This is the example of thinking of philosophy as that which creates puzzlement so that you can make progress. Just quick summary. There's a few different ways of thinking about what philosophy is that we've looked at. One is that philosophy is a set of topics, and then that raises the question what unifies those topics, and we looked at two answers to that question. One is at least the first three all deal with prescription, all deal with should, ought, norms, and all four deal with essences. We then looked at the possibility that philosophy is that which does certain jobs, one job being to theorize, where science is silent, another job being to serve science by clarifying foundational concepts, and another job being to problematize, to create puzzlement. By the way, this is the job that Socrates liked. He liked to go around creating puzzlement. The final way of thinking about what philosophy is you can think of philosophy as a set of methods, and that's what we'll look at next time.